Independence and dependence, okay, just depends on if something affects something else. Independent events are when the outcome of one event does not affect the outcome of another event. Okay, so what I mean by that is, let's say I choose somebody at random. Then I go again and I choose a different person at random. Whoever I chose the first time isn't affecting who I choose the second time. Okay, that's independent. But let's say I change it and I say, okay, I'm choosing the first one. The first one I'm choosing is a guy. The second one I'm choosing is also going to be a guy, but I can't choose the first one again. Now I've changed and I put stipulations on what I'm doing, so therefore I have to, it's a different and they're dependent on each other. Because now I have one less person I'm choosing from. Does that make sense? Okay. So independent events. If you have independent events, what you're going to do is you're going to take the probability of the first event and multiply it to the probability of the second event. It's that simple. If you have dependent events, you're going to take the probability of the first event and multiply it to the probability of the second one after, I can't spell, A occurred. Okay? Which means you are now taking your total and taking one away from it. Okay, so a die is rolled 3 times. What is the probability of getting ones on each roll? Does what I do the first roll affect what I do the second roll? No. So therefore, they're independent events. Okay? The probability of getting a 1 on the first roll is 1 out of 6. The second roll is 1 out of 6. The third roll is 1 out of 6. And you're just going to multiply them all together. So your answer would be 1 out of 216. A coin is tossed, and then a day of the week is selected. What is the probability of getting tails? Then a day starting with the letter T. Does me tossing a coin affect me choosing a day of the week? No. No. Whatever. It's not like I'm saying if I choose heads, it's going to be Monday. Okay, I'm just literally flipping a coin here and then choosing a day over here. So they're 2 separate events, not affecting each other. Okay, what's the probability of tossing a coin and getting tails? 1/2. Multiply, what's the probability of selecting a day of the week that starts with the letter T? 2 out of 7, not 5. So that'd be 2 out of 14, which reduces to 1 out of 7. Okay. A bag of crayons contains 8 red, 14 purple, 6 yellow, and 4 green. A crayon is randomly selected, replaced, and then we select another crayon. Are these going to be independent or dependent events? Independent? Why? Yes. Okay, they are independent events because I am putting the crayon back after I select it. I'm replacing the crayon. So anytime you replace something, it is always independent events. Okay, so what's the probability that I have a purple crayon? 14 out of 32. You mean the 8 at the beginning of the sentence? Okay. What about yellow? 6 out of 32. I will make a highly suggestible thing. I would reduce these before you multiply them. Makes it a little bit easier. Okay, so you get 7 out of 16 times 3 out of 16, which gives you 21 out of something. 256. And I believe that doesn't reduce anymore. So that is the probability that you select purple, then yellow. What about green, then red? So what's the probability of green? 4 out of 32 times it by red, which is 8 out of 32. 4 out of 32 is reduced to 1 out of 8. 8 out of 32 is 1 out of 4, so it's 1 out of 32 chances. Two purples. You have 14 out of 32, and then it's again still going to be 14 out of 32. Why? Because we put the crayon back. So 7 out of 16. 7 out of 16 gives me 49 out of 256, and I don't think that goes any further. And then yellows, 6 out of 32. Times it again by another 6 out of 32. These reduce to 3 out of 16, which gives me 9 out of 256. Okay, so now we're doing the exact same thing, but now read what we're doing. We're not replacing the crayon. Okay, so same numbers, same things we did above, but this time we're not replacing. So what's the probability of selecting yellow, then red? So first, what's the probability of selecting yellow on the first try? 6 out of 32. Times it by, what's the probability that I'm going to select red? 8 out of 31, because now we have one less in the bag because we pulled a yellow one out there, assuming. Okay? So 6 out of 32 reduces to 3 out of 16, which gives me 24 out of 496. And this does reduce, I believe. I think 8 goes into both of them. So it's 3 out of 62. Same thing for number 18. They want me to find the probability of purple, then green. Purple is 14 out of 32. Green would then be 4 out of 31 because we have one less in the bag. So that's 7 out of 16. Times it by 4 out of 31, which gives me 28 out of 496. And 4 goes into both of them. So it's 7 out of 124. Okay. Then the probability of doing 2 reds, well, 1 red would be 8 out of 32. What would be the second red? And why? Why is it 7 out of 31? We're assuming the first one was red every time we take the second one out, so that's why it's one less on both the numerator and the denominator. So this is 1/4 times it by 7 out of 31, which gives me 7 out of 124, which happens to be the same probability as the other one. All right, same thing with 2 greens. 4 out of 32, then multiply it by 3 out of 31 because you've already taken a green one out the first try. So that's 1/8 times it by 3 out of 31, which gives me 3 out of 248. And let's see, does 3 go into that? It does not. So that's my probability. It says a card is drawn from the deck. Okay, not replaced, and another is drawn. Okay, find the probability that you select a heart, then a spade. Okay, so the heart would be 13 out of 52. Okay, because there's 13 of each suit. We're going to multiply that because we're not replacing it. It's going to be 13 out of 51. 13 out of 52 is 1/4. So it's 13 out of 204, and I don't think 13 goes into that. It does not. So that's my final probability. Jack had 4 Snicker bars and 8 Mars bars. He randomly chose a piece of candy, ate it, and then chose another. What is the probability that both candy bars were Snickers? Okay, I'm assuming that because he ate it, he didn't replace it. Okay, that would be gross. So therefore, we're going to do a dependent. So it's 4 out of 12 times it by 3 out of 11 because he ate a Snickers and we're trying to get another Snickers. So 1/3 times it by 3 out of 11 gives me 3 out of 33, which reduces to 1 out of 11.